Alright, so this lesson is a shout out to Dr. Smith at Otterbein, who apparently does still remember me. So I have referenced many times this year, oh, Dr. Smith would say, and he was my teacher at Otterbein when I took a class called Axiomatics by Inquiry, which is really a fancy way to talk about how do you teach math. Not just how do you do math, how do you teach math. One of the things we did that I will always remember is iterated in this little mug, which I can pull the inside out of it. And this says, and this was from 2011, if you want to try to date me, make me old, make me feel old. Not like me. If you want to take me on a date, I will take a free dinner. Anyway. So this says better than Pythagoras, right? Which is pretty bold to say that I'm better than Pythagoras. And on it, you'll see a little picture here. And I should probably just show it on the dot camera. And I bet he'd probably be surprised to know that I still have this. But so it says, better than Pythagoras, right? And the picture is this, which is pretty interesting. We are going to work to get to a point where we can model that. Now, before we get to modeling that, we have to understand, well, what the heck is that trying to show? So what you have in front of you is a variety of squares, right? What you and your team are going to do right now is create different arrangements of those squares so that 3 of them connect to make a triangle. We are then going to document, is it an acute, an obtuse, or a right triangle? What do we mean by that? Who can describe the difference between an acute triangle and an obtuse triangle? Up, down? No? Yes? Yeah?
So acute is when the triangle has angles that are...
All of the angles are... Yeah, so in an acute triangle, a cute little triangle. In an acute triangle, all angles are less than 90. Not save, what am I doing? So you might want to write down somewhere on your paper, acute triangles, and we could label this triangles. Acute means all angles less than 90 degrees. Less than, not equal, less than. Right? Yes, because it's a triangle, right? We know they have to total to 180, so thank you for the clarification. Obtuse, a little different. There's no all. An angle, that's a bad angle symbol. An angle is greater than 90 degrees. And this will be that, well, of course, moment. A right triangle has what? Has a right angle. Let's just say 90 degree. So if I don't like how it looks. Has one 90 degree angle.
It's not possible that 290 degree angle.
You are correct, because that would be all 180 degrees, and a triangle has to have 3 angles and total 180, so it would not be possible to have more than 190. So you could just say has an angle of 90 degrees, or has a 90 degree angle, but it's just one. Patrick?
So would it work to have a right angle and another angle that's 89 degrees?
What would your third angle be?
1 degree.
Would that work?
Yes.
Yeah, that would 3 angles. Do they total to 180? Yes. It'd be a very, 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 very narrow triangle, but it would work. So here's your task to review. You and your team are going to align your squares to create various triangles. Then you are going to document what is the small, medium, and largest sides of said triangle that you made. What are the areas of the small, medium, and largest sides that you're using? What is the combined area? I guess I can make this a little bigger. Is that equal to, greater than, or less than the large area? So notice this is just small plus medium. Be careful, that's just small plus medium. I can't write on this screen, but that's small plus medium. This is large, right? And then, can we classify it as acute, obtuse, or right? I'm going to give you probably 11 minutes at least to do this, because that will put us at 11 o'clock. What questions are there about the directions? I'm not taking math questions right now, but direction questions. Sure, yeah. And then what type of triangle has two sides the same length? Not right. Well, it could be right. Isosceles, right? Henry? Isosceles.
Okay, so.
Hold up. Henry. Keep racking your brain. We'll come back to you if we can. Fair? So your squares have the areas on them. So this square is a 10 squared. Its area is 100. Right? So you have the edge length is given to you, and then the area is given to you. So you literally physically are going to arrange triangles, or arrange the squares to make triangles. Now, not every 3 squares you have can make a triangle. So there are some arrangements that you'll be like, oh, these 3 don't work. That's okay. Find 3 that do. Does that make sense?
Yeah, and the sides are like the sides.
Yeah, like you can count boxes, like literally the graph that you see in the squares, those are unit boxes. So it's 1 unit by 1 unit, it is 1 unit squared. But if you're 2 units by 2 units, that's 4 units squared, right? Because 2, 2, 4. Any other questions about directions, what you're doing? Okay, giving you at least 10 minutes. I'll take a question from you. You just did. You just put them together, and you made a triangle. Whose group are you working with? Anyone else need the 921 homework page?
Should we label it as 10U? 10 units?
Sure. Yeah, I mean, you don't even have to put U. Hey guys, we'll just go ahead and say you don't have to put labels. If you want, though, you could do just units or unit squared, so U or U squared. Yeah.
Not all sides. That's a good need. Okay. Small one side is 8, 6, and 7, 8, and 12. And areas of the small meter, we don't need to say 6, then 100, then 144. This is going to go for 7. No side in the same.
Hey, so don't be creeped out when I walk around and like steal data from your paper, because I'm just gonna walk around each group and like steal some data.
He's stealing my dating space. Facebook is stealing all of our data. New square. It's right there. Wait a second. If it's isosceles, that means 2 angles are the same. Also 2 sides. No, this is length side.
Are you actually making triangles? Alina, are you actually making the triangles? So you're writing down nonsense. You don't actually know if those make triangles. Alina, would you follow the directions, please?
Why are you taking squares with it?
Oh yeah, because it's squares in the
Don't spend your time arguing. Those will not all be the same, I guarantee you.
What are the rules of each triangle? Those two must be equal that.
What?
I'll take these scraps of paper if you have them as I come out. These scraps of paper. Crystal, if you want, Alina's down here. She cut out squares. She's working. I had to force her to actually make triangles though, so you can make sure that she keeps in line over there. Trying to go rogue and not follow my directions. Not all of the sets I've given you can actually make a triangle. Look, what you're doing essentially is disrespecting that Dr. Smith taught me strategies for teaching people. And I was trying to make today like a shout out to him because he said hi to me through Miss Kerrigan. Like Mrs. Bouldering student teacher person that you're in that group with. She came to me yesterday and was like, oh hey, Dr. Smith said hi. I was like, I can't believe you remember me. Like, because how many students teachers see? And that was 10 years ago. Well, 8 years ago. It was 2011, like according to that mug.
Damn, triangle.
I'm trying to predict what is that? Come on, 208.
We're sure 6, 8, 10 works. I mean, it looks like it, so okay. Give me another one, Xander. 3, 4, 5, 10, 12, 13. Alright, keep going. 4, 5, 6. Does that one work?
Dude, I just had a triangle.
Yeah? Okay. Nice.
It's a triangle.
That's not a triangle. That's a triangle. You only have 2 angles. Triangle has to connect to make 3. Now you made a quadrilateral, which is not a direct angle. So, I mean, imagine this desk. The desk is the bottom. This is one side. This is one side. They don't connect. They're not long enough to connect. There's 2 angles. But that's why I'm not 13. I agree with you, but what is the length of that side? It may not be. Couldn't you just swap it out with a and do like 10? You do that? Lay this down like that. Scoot this over. That would work. It'll connect eventually. So I'm going to write that out as 3, 8, 10. I don't know what colors to use.
Oh, this is right angle.
Yep. I don't know why you would even make a triangle. I just want to say what he said. I was like, make a triangle.
Yeah, I know.
Yeah, I
There are
know.
some that won't work.
I know.
8, 12, 13. What kind of triangle?
I mean, do they connect? Do they make a triangle? It doesn't have to be perfect, but they can connect to make a triangle. So 6, 10, 13, I'm going to write it down.
Oh yeah, you're right. Some of them it is
Do you trust me at this point?
really small, you cannot make them at a big enough thing that.
You know what that theory is called? Have you ever heard? It's called the triangle inequality theory. And that's what we're about to learn. The reason why. I mean, could you state that to your class of why it doesn't work?
Basically, if you take the side lengths of both of the two tiny ones, if they both adding up, not everyone does it. Oh, I thought it was the side one. It looks pretty close. Because side lengths are adding up is basically what it is at one.
Yeah, I agree with you. Because I'm going to call on you to explain this to your classmates.
Wow.
If this is the base of your triangle, now let's check this out. This is going to end up too long. See, that spans the gap, right? So we can make a triangle. But if instead of that, you have this, can my side connect to your side? No, right? Like, it doesn't make sense. So, do you know what we could say about, if we call these sides A and B, you know what we could say about these two sides compared to the third side?
Yeah, basically, just A and B, A plus B is less than C.
Other way around. Well, right now, yes, but to make a triangle, A plus B has to be greater than C. Because if A plus B is C, it's flat, right? If A plus B equals C, but as soon as we lift, A plus B is more.
Greater than, that means it can be 0 at an angle of 0.0005, infinite zeros, 1 degrees, and that's how
yeah, isn't that cool? Cool or frustrating? I don't know.
it's just like, dang, I can't make a triangle.
And that old question, like, can you make a triangle with 1 degree? Well, yes, but you might not really be able to see that it's a triangle.
Yeah.
You know what I mean? It barely opens. All right, 60-second warning. But that's my name. His time keeps marching on, and you know, we all have a limited time. Huh? Hazel thinks she found a pattern. Hang on to it for 47 more seconds. You will.
Oh, wow.
20 seconds.
Okay, I've yet to
Just the one thing? There's only one? Oh, it depends on what angle you're looking at. So, it doesn't even matter if it's right, but let's say this is a right triangle and this is my theta. The adjacent side is the side that is not the hypotenuse touching the angle. So this is a leg, right? Because it comes from the right angle. This is the hypotenuse. It cannot be the adjacent. Because hypotenuse is always hypotenuse. It doesn't matter if it is adjacent, right? The hypotenuse right now is adjacent to the angle. But we call it, yes, but if this is our theta, okay, so this is the angle we're referencing. So let's say you're doing, so you're talking about adjacent, so cosine of theta, this is the angle we're looking at. Now cosine uses adjacent over hypotenuse, so the adjacent leg is this one over the hypotenuse of this one. Because that is opposite the angle. It's across. Remember, adjacent means next to and touching. That side's not touching the angle. That's how we know it's opposite.
If we have this, how do we know which one's the obtuse?
It depends on what theta you're looking at. Grab a seat. We're not doing trigonometry yet. You and I can talk more after class, but I've gone way beyond the minute that I told them.
Is it just like a one part?
Audrey's not here, right? Oh, yes, she is. Or Hudson. No.
She's not here. She's either in New York, Florida, big thing on her. Thursday.
Yeah, so she'll be here Monday, Tuesday, that's it.
Yeah. And where's the
Hazel! What do you mean no? I just gave you like 2.5 minutes on a 1-minute warning, so no complaints. Hazel, you said that you believe you found a pattern.
When the small area plus the medium area is larger than the large area, it's a cube.
So wait, so when the small area plus the medium area is, did you say smaller or larger?
Larger.
Because you're just standing here and it's weird. Not really, because it makes me uncomfortable. And you can't see the board.
I can't tell which one of you guys is actually the teacher.
Let me guess, you did that to Dr.
No, I never stood up at the board with Dr. Smith. No, I never did that.
Oh, hello there.
So, this area is, everyone grab 10, 12, 13. If you, I mean, you might have already looked at it. But when we arrange those together, does it look like an acute triangle or an obtuse triangle? Acute. Now, I don't know if I have. Can somebody give me an example of what makes an obtuse triangle?
Yeah.
Alex?
5, 6, 10.
5, 6, 10. So 5 squared, 25. 6 squared, 36. 10 squared is 100. So those added up is 50, 61. Is less than 100. If you grab 5, 6, 10 right now, it can make a triangle, but it's an obtuse triangle. Logan, are you able to show what we talked about with the rulers and the things?
Yeah.
So when you were arranging triangles and some of them didn't work, Logan and I were having a conversation investigating this. I'm going to see how well he can teach. Try to explain the topic we were talking about.
Okay, so basically,
You want me to hold your third side? I will hold your third side. Yes.
Oh, yeah, so if the two sides are...
Bobby said,
okay, I guess I don't need
if
that.
Logan can't explain it, you're tapping in. Logan? Do you want to explain it or no?
I guess, yes. Okay, so basically,
Listen to Logan.
if you have angle A, B, and C, sides A, B, and C, then if A plus B is less than C, the side lengths of A and B is less than the side length of C, you cannot make a triangle.
Show why. Put them on the ends.
Because if you put them at an 180 degree angle right next to each other, and then you just lay them down, they won't make it. Doesn't matter. Even at like an infinitely, impossibly small angle to have for a triangle, they just don't work.
So on the sorry, go ahead.
So
On the flip side of what he's saying, if we imagine we make the vertices, right? We make the angles. And I talked to a couple groups about this. I can make 2 angles, but can these connect?
no.
So Avi, even if we put them flat, right? Like at the smallest angles possible. So Avi, why did your mind just blow? What do you like?
I remember we got taught this a long time ago, and then I finally remembered it because if you had 2 small rulers and then a long one.
We're gonna write down a rule. So somewhere we're gonna write down this. This is what we call the triangle. No. Inequality theorem. If we have a triangle A, B, C, doesn't matter right triangle, obtuse triangle, acute triangle, does not matter. what Logan just told us, and Avi's brain just splattered everywhere, is that if I have sides A and B added up, and they only equal C, it's not a triangle. It's flat. So to be a triangle, A and B must be greater than C. But also what that means is if I added A and C, they'd have to be greater than B. Or if I added B with C, they'd be greater than.
To the remote office, please, Caitlin Young.
So these three inequalities must be true. All of them. All three of these must be true to make a triangle.
They're always right.
If they're always right. Like my wife, right? No, seriously, she knows what she's talking about. She's always right. She pretty much always knows what she's talking about. So, if we come back here, so wait, 3, 4, 5, so that was 9, 16, 25. This makes 25, and this is 25. When there's equal, that's right. Right now, 36 and 64, what do these add up to? Enough. 100. And, well, that's equal. So that's also right. Who's deeply confused?
That guy.
Henry, why are you deeply confused? What, the 3, 4, 5 or the 6, 8, 10 or which? So, let's check out the y. How does 6 relate to 3? Or 8 relate to 4? Or 10 relate to 5? That's just a dilation. Those are the same triangle, essentially, just one is twice as big as the other. Henry, you're like half in my classroom, half out. Does that make sense? That it's the same thing, just double, double, double.
More, you can even see it.
Hey, stop. Alina has something to say.
That's what like people that design buildings use because like you need a right angle for a building or else it'll like
Fall over.
yeah, it'll fall over. And so if you just like multiply each side by the same number, it's like ratios. You just multiply each side by the same number, then it'll always be a rectangle.
And those ratios, and she said, oh, it's just like ratios. That's what we call the scale factor, right? So this purple compared to this red is just a scale factor of 2, right? It just doubled it. So likewise, I could scale factor 3 and say 15, 12, and, wow, Micah, 9 and 12 and 15. That's where my brain was thinking first. We could scale with any. So, hopefully what you've seen here and what you have written down agrees with if these two, my two smaller triangle, or two smaller areas of those squares, is greater than the third, it's an acute triangle. On the converse, if the two smaller squares are less than the bigger square, it's an obtuse. And if they're equal, it's a right. Question. Henry, question? No? Questions?
So there are like different right angles.
Whoa, there are different right angles. What do you mean by that?
Like there are different side lengths for a right angle, right?
Yes, but when we talk about a right angle, all we care is that it's 90 degrees. Are you talking about a right triangle?
No, like a right. Yeah, that's what I meant.
I like how you say no, and then you say yeah. You just want to say no to me.
No, yeah.
No, yeah. Sorry, I had the wrong binder out. Give me a second. I got to make sure that I've covered what I want to cover. All right, so So this, guys, hold up. Here's what I'm scared about. This deals with side lengths. Our handout here was dealing with the area comparisons. Okay, so let's check a couple of these out and see what we actually can determine based off the side lengths given to us. So, you and your team need to investigate these 6 triangles and decide, are they acute, obtuse, or are they right? And apparently we're out of time. So, pack it up. We will pick up here on Monday. Patrick. You can have an isosceles right triangle. You cannot have an equilateral right triangle because all legs the same. So, to make an equilateral triangle here, we'd have to have 3 squares the same size. Right? If an isosceles, then we'd have to have 2 squares the same size. That's why we didn't see any of those. Right now, here, 5, 6, 7, 2, 11, none of those fit that criteria either. So you're right, there are the other types of triangles, but we're not dealing with those today.